Hello everyone, welcome to my channel. Here we are having question number 6 from exercise which is there in page number 111 of chapter 9 Gravitation. Here we have the question, what happens to the force between two objects? Force between two objects. What happened or what conditions will be there? If the first part is if the mass of one object is double. The case 1 I am taking, mass of one object is doubled. Let us take this case first. We know what we know from universal law of gravitation, that capital F is equal to capital G, capital M, small m upon r square. Capital M is the mass of one object, small m is the mass of another object, r is the distance between these two object center. Now they are saying that mass of one object is double. So I'm considering that the mass of second object is getting doubled, so it becomes 2m now. Now if I apply the universal law of gravitation here, so capital F equal to capital G, capital M, and the mass of second object now becomes 2m whole divided by r square. Now it can be rearranged, capital F equal to capital G, small m, capital M, multiply with 2 divided by r square. Now this particular part can be written as f dash, can be written as f. Now as the mass of the second object is getting doubled, so the force of attraction will become changed. So I am writing as f dash here. So f dash equal to capital F multiplied by 2. So I can see here the new force of attraction between the objects due to the condition that one of the object mass is getting doubled, it becomes 2 times the previous force of attraction. What? It becomes 2 times. Now the second part of the question is, what happens if the distance between objects are doubled and tripled. The first case I'm taking as the distance between the object is getting doubled. The r becomes 2 times of r. Now if I apply the normal condition for universal law of gravitation here, F equal to capital G, capital M, small m upon r square. Now we can see here that the distance between the object is getting doubled, so it will be a new force of attraction. Capital F dash will be there, change will be there, then capital G same, small m, capital M will be same, and then r becomes 2r now, so it will be 2r whole square. As the distance between the object is getting doubled, this will be 2r. Now if I solve this one, f dash will be equal to capital G, capital M, small m upon 2 to the 4 r square. Now this part, this capital G, capital M, small m upon r square can be written as f. So f dash will be equal to 1 by 4 times the previous force of attraction. So we can see here the new force of attraction between the objects is getting 1 by 4 times the previous force of attraction between the objects if the distance between the object is getting doubled. The second part of the question is, what happens when the distance between the object is getting tripled? So r becomes 3 times of r. So if in the normal condition, f will be equal to capital G, capital M, small m upon r square. Now as the distance between the object is getting tripled, so f dash will be the new force of attraction, capital G, capital M, small m upon r, it will be not r, it will be 3r whole square. Now f dash will be equal to capital G, capital M, small m upon 3 to the 9 r square. Now this capital G, capital M, small m upon r square can be written as f. So new force of attraction will be 1 by 9 times the previous force of attraction when the distance between the two objects is getting tripled. So this is how we will solve the second part of the question. Now going for the third part, that is The third part I'm solving here. Here the question is, what happens when between the force of attraction between the objects when the masses of both the objects are doubled, means the small m becomes 2 times of small m, the capital M becomes 2 times of capital M. What happened under this condition? Now if it is a normal condition, F equal to G capital M small m upon R square, and if it is the mass of both the object is getting doubled, so a new force of attraction will be there between the objects, so it will be capital G, the M becomes 2m and small m becomes 2m divided by R square. Now F dash will be equal to G capital M small m upon R square, and 2 to the 4. Now here F dash will be equal to, this part can be written as F, so F dash will be equal to F multiplied with 4. I can see here that the new force of attraction under this condition becomes 4 times the previous force of attraction between the objects. So this is how we will solve question number 6. Hopefully all the students who are viewing this video will be able to understand the steps involved for getting the solution.